Yes, please. You can start. I think we have started recording. Mr. Srinivas, are you there?
Hi, Ganguly, you there?
Yes, yes, yes. You can start the session. I can make you the host again.
Okay, please. All right, so let me share my screen. All right, so we have the traditional way of building servers, building workloads, right? So they have started from on-premises and then data centers, and then the latest era is like cloud, right? So even cloud itself is like building virtual machines in cloud and virtual networks, virtual storage is a um, tedious job, right? So this is where the focus is all about automation, right? And if you see the current infrastructure challenges, so suppose if you wanted to plan any change, right? So the change can be like deploying hundreds and thousands of servers for various applications and various environments that can be even production, development, QA, pre-prod, prod, etc. Right? So that is one aspect, and the other aspect is like executing those planned changes, right? So we never know whether that change is going to be successful or going to be failed. If there is a failed change, then there is a huge impact, right? So and again, so we need to go back to the customer with reasons, and there will be penalties like SLA penalties and customer satisfaction. All those parameters will come into picture if there is a failed change, right? And there are multiple teams together involved to implement any change, like if I need to deploy certain servers, right? So in that case, so I need to work with computing system administrator like VMware administrator, and I need to work with OS administrator, and then if there is a database to be hosted on it, right? So then I need to work with a DBA, database administrator, that can be Oracle or SQL DBA, right? And what about network? So I need to work with network for the networking part, and what about storage, right? So storage. So these many stakeholders we need to engage with to execute and to plan any change, right? So and so we need to one more challenge is like so we need to, after the successful change, so we need to keep those inventories up to date. So we need to update like inventory database has to be updated with all those new additions or new deletions, whatever it is, right? So these are the currently challenges which the industry is facing. And when it comes to DevOps, right? So, so DevOps era is like, kind of, it is a culture most of the time with automation, measurement, and sharing, right? So when I say culture, so it can be like, your ideal process or agile process or, kind of approach. And automation is like, suppose I need to deploy certain servers with pre-built configured applications and databases, right? So all those things we can automate, right? Through CI/CD pipelines, right? And measurement like how we measure the successful deployment, or the successful change, or the successful building, right? So this is all about typical DevOps principles. And when it comes to automation, right? So when I say automation, it is all about automating things. So that can be building a server, or building or rebooting a server, or restarting a server. It can be anything, or building application, or restarting, or changing the application code, etc. Right? So all those things will come. And version control. Suppose so there is an inventory with version, certain version, right? So whenever there is a change in the infrastructure, right? So suppose infrastructure, there is an infrastructure which is with 1,000 servers hosted in a typical data center or in cloud, right? So all those 1,000 servers are captured in the inventory, and whenever there are additions or deletions or any changes in the infrastructure, right? So immediately that inventory document has to be updated, right? So this is one kind of example when it comes to data center workloads. And if you take now the code, like programming code, right? So it can be like a version, application version 0.1, right? So today it is 0.1. After upgrade, it can be 0.2, right? So those kind of version control can be automated. And continuous integration and continuous deployment, right? So these are DevOps tools. And one more feature, which is infrastructure as a code, right? So today, so our primary focus is on infrastructure as a code. So using Terraform, how we automate the infrastructure related activities using Terraform, like as a code, right? So Terraform. So Terraform, so it is an open source technology. So it is created, is developed by HashiCorp, right? So the same organization which is developed Vagrant, Consul, Packer, and Vault technologies. So basically, it is started in year 2014, right? And Terraform is written in Go language, right? So it is written in Go language, and it is a kind of pluggable architecture. So you can plug this Terraform anywhere. It can be any cloud, like your Azure or AWS or IBM Cloud. So it can be anything. So even you can use the Terraform even in your on-premises virtualized environments as well. So that is the reason it is pluggable component. All right. What is Terraform, by the way? So Terraform is a tool to build and to change and to version control.
Guys, we can't hear you.
Yes, I just checked with Srinivas.
So let me
Yeah,
do
you can
that.
do that then. You can do that. We can start doing it. Okay. Yeah.
Yes, yeah. It is recording right now. Okay. All right. So as I said, so Terraform is a tool uh, um, to build the infrastructure and manage the change and for version control your whole infrastructure, right? So it is like simple code, like right. So this is the primary purpose of the Terraform tool. When it comes to the other features, like so it can be used like your IaaS, like infrastructure as a code, IAC, right? So it is a tool so which can manage your virtual server life cycle. So that can be on premises, and that can be on AWS and Azure or any cloud, right? So any cloud, including on premises. And this tool, Terraform, it supports the management features like DNS and email, right? So why DNS and email is required is like, it can be configured to trigger and alert the specified users, right? So if there is any abnormal change, or if there is any, abnormalities within Terraform, so it can be configured such a way that so those abnormalities, warnings, and critical alerts can be sent to pre-configured users, right? So using a DNS. All right. And also it is a tool to manage your system services using MySQL and PostgreSQL, right? So the database which Terraform supports is like MySQL and PostgreSQL. And the configuration files within Terraform can be like your HashiCorp, CL, SCL, or JSON. So these are the two files which are supported by Terraform. And Terraform, so anyway, we know, so it is a product by HashiCorp, and which is written in Go language. So this is the typical Terraform workflow in a typical DevOps workflow. So see here, so there is a Git push, right? So using Git push, so we can deploy a traditional or kind of S3 bucket from AWS, and we can use our Terraform component, integrating all the clouds, like multiple clouds like AWS, Azure, and IBM Cloud or Google Cloud, right? So see here how the integration happens. So we can configure Terraform such a way that from the single console, right? So from the single Terraform console, we can control multiple cloud infrastructures, right? So of course there should be connectivity between the Terraform environment and the target infrastructures like AWS, Azure, or Google Cloud, right? So it works the same way, like how the Ansible works. So Ansible primarily focuses for kind of Red Hat workloads, right? So whereas Terraform, it doesn't have such restrictions, so it can support any workload. So all right. So using Terraform, so we can build infrastructures, and it can talk to multiple cloud infrastructure providers, right? So from the single dashboard, and it ensures creation and consistency across clouds, right? And it is kind of API driven tool, like so this tool can be integrated with various APIs, which can be can be from multiple cloud providers like Azure, AWS, and other cloud providers, if there are any, right? So so it is an API driven technology. And using Terraform, so we can change the infrastructure, like we can do incremental changes to the existing infrastructure, like suppose my current infrastructure is hosted with 100 servers, right? So and tomorrow I need to add 10 more servers, right? So I can do that. So I just need to make the additional 10 servers in the code, and then apply that code, and then I'll get 110 servers will be readily available on any clouds, right? So that can be again any cloud. And I can even destroy, so when I don't want any additional loads to save the costs, right? So I can destroy unwanted workloads, unwanted servers, right? And I can do kind of preview changes, right? Like suppose if I wanted to implement certain change in the infrastructure, right? So I can do kind of preview, like whether this particular change is going to be successful, or are there any other dependencies or other bottlenecks, right? So it will highlight. So those kind of preview it will give. And scaling is possible, right? So we can scale up and scale down. So I can reduce the servers, or I can increase the servers as and when required. So on the fly. So I don't want any kind of downtime, or any no business impact, right? So like that. And it provides version control assistance as well. So it will keep maintain the registry with all the versions, since beginning of the deployment, right? So today, so I have deployed my infrastructure with version 0.1, right? So after 1 year, so that version can even go to version 0.100, or version 100, right? So all those version control will be there, and that takes care by Terraform. All right. So now let us discuss about Terraform concepts, like kind of features and Terraform architecture. So Terraform, it has the component like variables, right? So variables, primarily it is kind of input to achieve certain output, right? So suppose I need to deploy 100 servers, right? So 100 is the input, right? So when I say 100 servers as the input, right? So it will go ahead and deploy 100 servers and produce 100 as the output, right? So that input can be configured at JSON or SCL or CLI, right? So we'll be discussing about JSON, SCL, and CLI in the upcoming slides. So this is all about variables, and output is like it is a specific text, right? So it can be anything. So suppose I said, so I want 100 servers to be deployed, right? So that is my desired state configuration, right? So I have set my desired state, and I triggered that. So immediately will the Terraform will go ahead and deploy 100 servers at the specified location with the specified configuration, right? So that is a output here. So there is a providers one more component within Terraform. So providers is like kind of configuration of your resource provider, right? So we need to call out. So like a provider is like who is the provider of resource? So is it on-premises, or is it VMware, or is it AWS cloud, or is it Azure cloud? So we need to call out that, right? So provider we need to call out, and we can be even call out DNS as well, right? And also, so most of the time, so it will be specifying through some kind of URL or API security keys, right? So this is how the Terraform knows and identifies the target destination location, whether it is AWS or Azure. So that is how it will go ahead and deploy the desired state configuration accordingly. This is all about providers. And so there are modules, right? So when it comes to modules, so it is a kind of group of resources, right? So as I said, resources can be anything, right? So resources can be your computing, and resources can be your networking devices and your applications. It can be anything, right? So and the module, so we need to configure certain parameters like for the desired output, right? And it provides the output, right? So it executes and then provides the output, right? So in this case, so deploying 100 servers, that is the output. So 100 virtual machines will be available on cloud. So that is the output here. All right. So we have plan component in Terraform. So basically it is like kind of it helps in planning the changes, planning the deployments, right? So suppose so I need to deploy certain applications, or certain computing, or certain storage, or certain networking, right? So I need to clearly call out all those requirements in the Terraform plan component. So there I need to specify like location. So in which location I need to deploy these many resources. So is it in India, or is it in US, right? Um, so we need to clearly call out so those kind of settings, and how much storage, and what about computing, so how many cores, and how much RAM, so all those things, right? And whether this is going to be a public instance, or this is going to be private instance. So all those details we need to configure in a plan parameter, right? So once we have all the desired state configuration parameters ready, and we are done with planning. So So then, so there is a parameter apply, right? So if we apply that, so it will just go ahead and do all the changes in the cloud, right? So we just need to trigger the apply module, and the apply module will go ahead and talk to the cloud provider, and then it will look for various options, like, so in which location the workloads are required, and what about storage, what kind of storage it is. So is it a performance storage, or is it block storage, or what kind of storage it is. So we need to clearly call out all those options, right? And how many cores. So all those information, based on all those information, so it will go ahead and deploy the target infrastructure. It is just like, kind of code. So you have specified all the parameters with the help of syntax in the code, in a HCL or JSON file, and you triggered that, you planned that, and then you applied that. As soon as you applied that file, and it will go ahead and talk to cloud provider and then execute accordingly, right? Then your infrastructure, your data center is ready on cloud. So it is as simple as that. All right. So there is one more parameter, so which is state file, right? So state file is kind of the current state of the infrastructure, right? So when I say current state, right, so it will clearly call out, so which is the version, right? So is it version 0.2 or is it version 100? So those details, it will be specified, and the file, right? So the file will be in locking mode, right? So then only nobody can change that configuration, right? So it will be stored in a file, and it is kind of in a secured manner, right? So that file will be stored in a secured manner. That can be even kind of using any encryption techniques, and that file will be in locking mode all the time. So unless and otherwise there is a new change to be deployed, to be planned and then applied, right? So till then it will be in locking mode. All right, so we have one more parameter, which is destroy, right? So when I say destroy, so we can use this destroy parameter to destroy the workloads, and to destroy that can be like your virtual machine, or storage, or networking, can be anything. So destroy is the parameter where we use to destroy the infrastructures and to destroy the data center, right? So suppose you have 100 virtual instances which are deployed in cloud, right? So if you wanted to destroy those 100 instances, right, so it is again kind of tedious job. So going through each and every instance and then deleting is a tedious job. So using destroy, right, so it is a single click kind of trigger command. So it will just go ahead and delete the entire infrastructure. All right, so so let me show you a small demo here, so with the help of graphic image, how we use Terraform HCL or JSON file for our configuration for the desired state. and to build the infrastructures, kind of automation and kind of infrastructure as a code, right? So this will be, kind of Terraform look like. So see here. So there is a provider clearly called out. So it is AWS. It can be even Azure as well, right? So there will be access security keys will be set, and there will be a region, like kind of location. So where exactly you are looking for the deployments for the workload provisioning. So which is the region, which is the location, right? And what about resource, right? So what kind of resources it is? So here it is S3 bucket, right? So storage bucket. And so my bucket name is like, my cool bucket. So this is the name I have given, right? And what about security? So is it public access or is it public read write, right? So for security, we need to clearly call out. So if it is public read write, so then it is a kind of risk. So anybody can access this bucket and then delete, or even they can modify. They can do hack also, right? So this is a typical configuration. So see, so there is a difference between Terraform and CloudFormation. See here. So here we clearly called out the reference point, right? And so the name of the bucket, and so the CloudFormation, right? So it converts it as like kind of. So it takes the type of the workload is like AWS S3 bucket, and access control is like kind of public read, right? So this will be like your output. So Terraform. So this is the input we are defining here, and that will be converted as the right side, like in cloud side, right? So so now let us go ahead and try how the S3 bucket can be created, deployed using Terraform. All right. So this is a typical JSON file. So where we configure the desired state parameters. So here I'm specifying my provider is like AWS, and the region is like US East. So this is a kind of location, and a resource which I'm looking for S3 bucket, and I am giving the name for bucket, right? And I'm specifying the environment type, like production or pre-prod or test or development, right? That's it. So this is the typical Terraform configuration file. So see here. So to deploy the S3 bucket, right? So we need to follow the plan, deploy, all those parameters we need to configure, right? So when it comes to plan, right? So the plan file contains these many parameters, right? The syntax primarily. So see here, ACL is private. This is a kind of a desired state configuration file, right? So ACL is a private, and bucket, see here, and destroy is 0. Force destroy is 0. If you see the bottom right, so 1 means it is adding, 0 means we are changing the existing configuration, right? So 0 here. And hosted zone here, compute and region and tags, and tag environment, like kind of prod or pre-prod or staging. And so if there are any kind of DNS names, so we can specify here website domain names. And if there are any website endpoints, right, so we can specify the endpoint as well here. So this is the typical configuration file. All right, so when it comes to apply file, right, apply module. So these are the, again, so if you see here, so most of the config files will be almost similar, right? So after applying the plan, so this is the output here. See here, so ACL is updated with private, and we have tag name like Terraform demo, and we have see here the bucket. So there is a message like creation complete. So we have our S3 bucket ready, right? So what are the changes it made? See here, apply complete, resources 1 added. So only 1 resource is added, and 0 changes and 0 destroyed, right? So this is a kind of brand new S3 bucket creation. So that is the reason. So there are no changes and there are no destroyed parameters. All right. So this is that's it. So we have our S3 bucket in AWS is ready. So this is the typical Terraform state here, right? So the version is 1 here, and the serial is 1 here. So if we make any changes to this, so the version will become 2, and serial will become 2 as well, or even 1.1 or 1.2, something like that, right? And modules and path within square brackets, and the root account, right? And outputs, resources. So we can call out everything here. And type, so type is like your AWS S3 bucket, and the ID which is used here is tf-demo, and ACL is private, right? And the location is specified here, and there is a tag, and there is an environment type, production, and is it Terraform? Yes. Yeah, so this is a typical Terraform configuration file with version, with first version. So because we just created S3 bucket, so this is kind of a new creation, no changes. It is a brand new creation of S3 bucket storage. All right. So now let us create a server, right? So we created S3 bucket storage in previous example. Now let us create server. Let us see how that can go. Okay, guys. So are you clear so far? So hope so. I am audible and I am clear, guys.
Yes.
Okay,
Yeah.
cool. Yeah,
Yeah, I have one quick question. So that
yeah.
load balancing and everything is handled by AWS framework itself. So Terraform is take care of it, or it's using the services which is AWS is providing?
Yeah. Good question. So AWS takes care of the load balancing at infrastructure level, right?
Yes.
So yeah, at infra level, at platform level. So AWS, at the end of the day, they are just providing platform for us, right? So when I say platform, so we do not know what kind of storage they are giving us when we order S3 bucket, right? I mean, when I say what kind of storage, like, what kind of storage boxes they have in the backend, nobody knows. And what kind of network they do have, and what kind of virtualization they do have, we do not know, right? So they do manage and maintain at platform level load balancing and networking techniques, right? So when it comes to our workloads, right? So suppose we do have three environments deployed. So one is prod, non-prod, pre-prod, right? So we need to do our own configuration, which are related to our requirement, right? So AWS, they are least bothered how you interact with your environment. So between prod, pre-prod, and within prod, so how you manage your workloads, like, between layers, like how your application servers need to talk to your web server, and how your DB servers need to talk to your app server, right? So those kind of design AWS will never provide us. So we ourselves, we need to take care that part. So that is where the Terraform comes into picture to automate those kind of things. You got
Okay.
it?
Yes. So is it a,
Cool.
a similar kind of tool like Jenkins, or for an
So
example, if suppose our
right. So
appli
yeah. So when it comes to Jenkins, right? So Jenkins is kind of it is not exactly similar, but it can be even used. Jenkins also can be used to automate certain functions. Okay. So
okay.
Jenkins, they are primarily focused on code level configuration, like, kind of continuous integration and continuous development, right?
Yes.
Yeah, those kind of things. Whereas Terraform, it focuses on workloads with the desired, so you can compare Terraform with Ansible, right? So Ansible, it provides the desired state configuration of your infrastructure. So it is like, infrastructure as a code tool primarily.
Okay.
Yeah, whereas Jenkins, you can automate your code level updates.
Yep. Got it. Yeah.
But Ansible is used for installation of several services as well. Does Terraform provide these features also?
Yes, of course. Yes, yeah. So it exactly does whatever Ansible provides. So we can automate many things within. Suppose you have many servers, like 100 servers. So you need to do certain change across all those servers. So you can achieve that using Terraform, the similar way like how you achieve using Ansible. That is possible.
Can we compare both these tools in terms of performance? Which one is better? And
So, so when it to see, so Ansible, so it is like kind of a Red Hat product, right? So I could see like so it is a Red Hat friendly product. So Terraform is like kind of a cloud friendly product. So like you have your workloads on cloud, right? So Terraform is a kind of a matured product to deal with cloud infrastructures. So whereas Ansible is kind of a product where it primarily deals with your Red Hat workloads and primarily kind of on premises as well as cloud as well, but uh, the context is different here. So the focus for Ansible is primarily on Red Hat products, and Terraform is like kind of cloud products. So when I say cloud, so that can be any platform, right? So that can be Microsoft or Red Hat, Linux, or can be anything.
but yeah, as per my understanding, Ansible also deals with the different cloud platform, public clouds through dynamic inventory.
Right. So that's what I'm saying. So in maturity of the product, right? So Terraform is more matured towards the cloud, right? So Ansible also it is a product so which primarily works with the Red Hat products as well as with the other workloads as well. Only maturity is the difference.
Okay.
Yeah, apart from that, one more question. What will be the prerequisite for the use Terraform in our project?
So if you okay, so you mean the requirements like kind of what kind of servers you need to use for Terraform deployment?
No, actually, for an example, our application is already hosted in Azure as well as AWS, and we want Terraform will be in place. So, what will be the prerequisite it will need?
All right, so you need to have so the Terraform infrastructure to be Terraform environment to be created. It can be at your on premises, or even you can create within cloud as well, right? And there should be connectivity established between the Terraform infrastructure and your cloud workloads. And from there, so you'll be just integrating, configuring all these modules, and then proceeding. So other than that, so there are no major requirements like kind of you should be having only these kind of operating systems like Red Hat or Windows. No, so you can host your Terraform tool either on Windows, even on Linux also. So there
Okay.
are no limitations. And from there, so basically you'll be setting up your Terraform tools infrastructure somewhere, and then extend your connectivity between your tools infrastructure and then your cloud workloads, and from there you'll be playing with whatever the activities you may need to automate or whatever it is, right? So it is very simple kind of activity.
Okay.
One more question. How Terraform manages upscaling and downscaling?
All right. So when it comes to upscaling and downscaling, right? So so there is a desired state configuration, right? So you will say like my environment has to be with 100 servers with certain type of storage and certain network and certain load balancing and a certain kind of storage type, right? So you will define all those things in your HCL or JSON file, right? So that will be like, your desired configuration, right? And so there will be conditions applied, right? So suppose I have a S3 bucket specified, right? So I'll put one condition. So my S3 bucket is configured with 1 terabyte of storage, 1 TB, right? So 1 TB means 1000 TB, right? So there is a condition specified in the desired state configuration, which is okay. As soon as my S3 bucket storage reached 800 GB out of 1000 GB, so you add another 1 TB storage to it, right? So the condition is matched. So immediately your storage, additional storage will be deployed. And the same case with workloads. Suppose you have a certain number of web servers, right? So you have many incoming connections, right? So your web servers are highly overloaded, right? So suppose so the utilization is more than 80%, right? Or the concurrent connections are more than 1,000 for my web farm, right? So that condition you will be calling out in JSON or SQL configuration file. So whenever the condition meets, right? So it will go ahead and trigger the additional workloads and add those workloads to your existing web form. The load will be automatically balanced, right? So your workloads are automatically scaled up, and the same case with scale down as well, right? So whenever you have very less utilization on your web servers, right? So suppose there are very few connections, so less than 100. Okay, then go ahead and remove certain web servers, certain web instances from my web form. That's it. So the scale down you achieved, right? So this is how you achieve scalability across your workloads. All right.
Yes, thanks.
Cool. So let us take a very little break here, so not more than 5 minutes. So let me just come back in another 5 minutes, please. All right, so thanks guys. So I am back. So let me resume the recording. So yeah. Okay, now let us see how the server can be created using Terraform. See the typical syntax configuration. So here we are clearly calling out the actual key pairs which are required for AWS servers, and what is the public key and what is the name, and the instance details, like what is the OS and what is the processor type and what kind of instance it is in AWS, whether T2 or T1 kind of details. And we are calling out key details and the name of the server, right? So this is the typical configuration file to create a server. So for that, so let us see the plan. So plan is like, your instance details with the server name, right? And here, so this is the second plan, because we have created S3 bucket in our previous plan. So that is one, right? And key pair details in plan. And then we'll be applying, right? So once the server is created, right? So it is like, so if there is an error while we create, while we apply the Terraform for building a new server, right? So if there is an error, it won't do some kind of rollback, right? So what happens? It will just go ahead and update the state file, right? So we were discussing state file, one of the component in Terraform architecture, right? So we need to, if the required VM is not created, then we need to go ahead and see this state file and see what kind of reasons why this particular workload is not created, right? So this is a kind of location where we can look at for the errors and all. Now let's try networking, right? So when it comes to networking, so we need to define CIDR block, the kind of IP range, and subnets, and your gateway, and then routing table, right? And then the other kind of ACL, security related configuration, right? So these are the typical configuration parameters we need to provide for VPC deployment. Okay, see here. So this is a typical file for VPC creation. So here, see here. So resource, we are calling the resource name, and the CIDR block, the IP range, and do we need DNS for this? True, if required. If DNS is not required, and if the DNS is already available for clients at their on-premises, then we can say false. And type of workload, is it production or staging? That's it. So see here the subnet details. So CIDR block and the location, in which location this particular network has to be created, right? And environment. So anyway, so these will be like, common parameters, right? And the gateway details, again, like, so that can be specified. So if we have our gateway details, so we can clearly call out all those things. And then routing tables also we can be specified. So see here, routing table, right? So VPC ID and all those routing table details. So see here, so if we need to send all traffic not matched by other routing rules to the internet, so then we can specify here. So this is where we control the routes, right? So the traffic to where and all the traffic has to be destination, right? And a routable association, again, like, kind of where the traffic has to be routed, all those things, right? So that's it. So once we have all these configurations available, and we can just go ahead and apply this particular configuration file. Done. So we have our VPC network setup is ready and available in any cloud. So that can be AWS or Azure. So that's it, guys. So with this, so I am done with this demo. So please, I am open for any questions, guys.
I think there are a couple of questions already there in the chat. Probably can we take one at a time?
Sure. So the first question is it possible to roll back the changes implemented? Yes, of course. So as I said, so so you have done one change, right? So from version 1 to version 2, you have done one change, right? So your version 1 is going to be there in your inventory. So you are not going to delete that version 1 file, right? So what you can do, you can just revert that by applying a version 1 to your infrastructure as a code. That's it. So you can do that. So that is possible. So what is the additional advantages in Terraform compared to other tools like, Docker, etc. All right. So when I say Terraform, right, so it is primarily focused on infrastructure as a code, right? So when I say infrastructure, so it is server, storage, virtual machine, network, all those things. When you say Docker, right, so it is a kind of a containerization. So it is a container technology, right? So you are doing multiple containers within single operating system. So technology entirely different. So this is automation technique, and that is containerization technology. So both are different. So that is the difference between Terraform and Docker. All right, so do we need to know Go language at some point while working with Terraform? So absolutely no. So we don't need any Go language. It is the similar way like, how Ansible is written in Python. So however, if you know Python or Go language, basics or fundamentals, I would say, you'll have, added advantage. However, there is no pre-requirement or kind of a requirement. There is nothing as such.
Maybe in case of Ansible, if we need to write a customized module, we need to know.
Yes.
So does it the same scenario with Terraform as well?
Yes, yes, yeah. Even in Terraform also, so you don't need to have any kind of deep level knowledge with Go language. Okay, so it is. However, it is better to have some kind of basic understanding how it works and how you can interact with the language. All just basic idea is more than enough.
Okay.
Okay, so the next question is Terraform agentless connectivity like Ansible. So this is I'm not very sure on this. So uh, this I need to check on this. So let me move on to the next question. So it is based on AWS credential to manage your infrastructure. It is not like Ansible agent based or agentless. I know Ansible is agentless. However, Terraform, so it should be almost it should be logically it should be agentless. So then only it will be able to deploy and configure easily. So that I need to check and I'll update. Okay.
But maybe if it is agentless, then how it keeps checking the various checks you have configured for upscaling or downscaling?
Right. Yeah. So why? Because so so you have your Terraform tools infrastructure somewhere, right? So let us say it is at your on-premises. Your infrastructure is on-premises, right? And you have one subnet here at your on-prem. So you need to extend your connectivity to the cloud workloads where you need to manage the workloads using Terraform. So that connectivity anyway has to be there. As soon as you establish the connectivity, right? So if it is agentless, right? So obviously it doesn't require any kind of special agents to be deployed on target workloads. So automatically it discovers and then push. You are right. So the next question, does Terraform provide any UI, maybe something like Tower? Yes. So you have UI kind of interface available for Terraform where you can do the basic stuff. All right. So also cloud, could you please discuss about Terraform configuration? What is that? Terraform configuration and requirements for configuration. All right. Yeah, I think we already discussed about this. So you just need to have some kind of environment setup for Terraform tools infrastructure, right? So from there, you'll be extending your connectivity between your Terraform infra and the actual workloads. And from there, you'll be interacting with and you'll be automating things. That's it. It is a simple, very basic setup. So it doesn't require any kind of high level like there should be 20 servers for each component like that. No, it is a kind of max 3-4 server configuration. All right. So in which file? So we need to write. In which file we need to write Terraform config related to VPC subnet routing. So the file can be like SCL or JSON, right? So it can be SCL or JSON. So they are the two files you have. do we have steps so by following which we can implement Terraform with sample application in AWS? So yeah, I can find that and then I can share that. Yeah. So how to debug? So this is the question. So when you say debug, right? So it depends on what kind of issue.
Yeah, in case of any issue, like in
Yeah.
case of we got some error, so if you the programming language we have debug, right? So step by
Right.
step
Right.
we can do the from the. Is it the
Right.
same way anything is available for debug in the for Terraform?
Yes. Yes. So yeah, if you recall, so uh, so there is a file, right? So state file. So this is a state file. So this is where the error logs will be stored. So if there is a failure in your automation activity while deploying something, while updating something, so what it does, it will write here. So you need to come back to this file and then look at. So it is a kind of your log file. All right. So
Yeah, yeah, I got that point. Is there anything possible like step by step which step it got failed and all? If any programming language you can go the debug, rectify something is there. You can go for each and every step. We can see that error. That kind of any
yeah,
console or something is there to while writing itself, not for the after applying or not for applying for that before
right,
that
right. Yeah,
itself. So
yeah,
I wanted to see
yeah.
that.
Yeah, I got it. So actually for debugging, right? So there is a 4 hour session. So actually only for debugging focus. So in that 4 hour session, so the topics will be covered like suppose you have automated certain server creation, right? So that has failed. So how do you debug, right? So there is this is one kind of aspect so where you look into and there will be other aspect like other workload creation or suppose you are working on certain application to push certain kind of features or this thing, right? So for that, so there are certain way of debugging techniques. So actually, so yeah, so those things will be covered in a detailed session. So sorry, I will not be able to cover those things at this moment. Okay, so yeah, they'll be coming under detailed session. Okay, so
Okay.
the next question, yeah,
Yeah, you just mentioned right that configuration file can be JSON or is any specific name we have to put for that configuration file and where it will be reside? For an example, if suppose there is a Spring Batch application, so there is a POM file, and in that POM file we will do the some sort of configuration and accordingly application work. So in case of Terraform, so how that JSON file we can put into the Terraform framework, so where it will be available. So we could do that configuration and we could use it.
right, right. So see, at the time of Terraform tools infrastructure setup, right? So suppose you would like to use Terraform, okay,
Yep.
to do activities to automate, right? So for that, so suppose okay, you have your environment has majority of Linux servers, right? So you will choose your Terraform platform as a Linux operating system, right? So you will install this Terraform package on your Linux machine and then do the basic configuration, right? So
Yep.
during that, so you will give the path, right? So where your Terraform configuration files has to be stored on your Linux partition, right? Right.
Okay.
So yeah, yeah, you will be referring the same path where you specified during your initial deployment of your Terraform tools environment setup. Okay.
Okay. Yep.
Yeah, yeah. And Okay, so which are the other similar tools present in the market? So yeah, we do have similar tools like Ansible. So as someone was telling, Ansible is there, and even you have PowerShell also, right? So using PowerShell, also you can automate so many things, and you have some other tools. So Terraform is there, Ansible, PowerShell. Yeah, there are many other tools, but these are the popular tools as of I'm aware. And one more question. And what is the advantage of Terraform over others? Yeah, we have already discussed this. Can we provision the infrastructure dynamically using Terraform SQL code like passing? Yes, exactly. Yeah, using various syntax and various desired state configuration with the help of SQL or JSON file. So we can dynamically scale up or scale down the infrastructures. All right, so can we customize the Terraform in order to create infrastructure on any private cloud? So when it comes to private cloud, right? So logically, yes. So when I say you can use Terraform for on-premises as well, so that means you can implement the same even in private cloud as well. So you just need to create your Terraform infrastructure in private cloud, and then extend the connectivity with other workloads, and then start playing. All right, so there is one more question, which is explain about code review feature. So in this case, right, so when it comes to code review, so most of the times will be as a automation architects or SMEs for infrastructure as a code, right? So we'll be most of the time we'll be working with the SQL config file or JSON config file, where we specify our desired state target infrastructure, and where we provide multiple variables with certain conditions for various dynamic reasons, like scale up or scale down kind of requirements, right? So that's all we do majority of the time as a automation Terraform architect or SME. Okay, guys. So meanwhile, please help filling that survey.
Also, if you can park, if you have any more questions, or you can shoot directly to Srinivasan.
Yeah, please.
So I hope we are done, and kindly fill this form fill the feedback details, and it will actually help us to do better in coming days. And tomorrow we have again one more session on Google Cloud, and day after tomorrow we have Splunk, and on Friday we have deep learning using Python and Keras, and on Saturday we have Alteryx, as we have mentioned. So you can join those webinars as well. I hope we try to cover as much as possible for this Terraform tool. Definitely we'll be coming up with more sessions, more detailed programs. I will definitely coordinate with the L&D managers, and they probably can channelize through you all the upcoming webinars, right? So with that note, we are winding up this session. We'd like to thank Mr. Srinivasa for taking time out and delivering this session. And also we'd like to thank, we'd like to thank all the participants. Yeah, all the participants for joining in the weekdays. So thank you so much, guys. Good night.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thanks, guys. Thank you so much.